Old World Industries is very excited to welcome you to Fluid Thinking. This is our education series offering product knowledge to assist you with your sales goals. Hello and welcome everyone. My name is Chris Alexander. I'm the Vice President of Lubricant Sales for Old World. We're excited to present to you Peak's new line of heavy-duty diesel motor oils. We hit a real home run in performance, beyond CK4 benchmarks. OEM partners are extremely pleased with our results, and customers will be too. Before we begin, we want your questions and feedback. You can submit them by typing in the box below. We will address as many as time permits at the end of our presentation. Today, we're going to cover engine design challenges facing OEMs and what they see as trending concerns, Peak's new diesel motor oils, and share some of the technology behind their development. Finally, we'll show results your customers will appreciate. So let's get to it. I'd like to introduce to you Terry Nolan, our new lubricants product manager for Old World. Terry, please share with our audience an overview of concerns among diesel OEMs and the challenges facing engine oil development.
Thank you, Chris. Yes. Hello, everyone. My name is Terry Nolan, and I want to thank you for joining us today. Our hope is to provide useful information to assist you in communicating with your customers Peak's advancement in engine oil performance and why we focused on certain areas and the benefits of choosing Peak motor oil. To begin, we have to talk about engine development changes. These changes have been focused for years, you probably know, under emission reduction and fuel economy. This has placed a substantial burden on engine oil. But let's go back a little bit and talk about that. In 2003, the OEMs introduced exhaust gas recirculation. EGR recirculates exhaust gas back through the combustion process to further burn off NOx emissions. It works, but at considerable expense in buildup and soot in the oil contamination. We saw increased acid formation, chamber deposits, and increased viscosity breakdown, forcing shorter oil drain intervals. In 2006 and in 2011, we saw an EPA mandate that forced a reduction of sulfur in diesel fuels. Now, the downside of this, from a lubricant standpoint, is it inhibited the diesel fuel's ability to lubricate piston chambers. So we saw a little loss there, but on the upside, in the oil, we saw a reduction in those soot levels. It was during this time that we also saw the introduction of selective catalytic reduction, or SCR systems, which reduced the need of heavy EGR. Finally, we come to today, and in 2017, we're seeing fundamental changes in diesel fuel combustion design, specifically fuel injection timing, delaying ignition to increase fuel combustion efficiency.
So Terry, didn't this increase combustion pressure?
Yes, it did. In fact, fuel injection timing raised ignition pressure and temperatures, resulting in more foot-pounds force in the same space, increased fuel efficiency, and it lowered exhaust emissions.
So what you're saying is there's a trade-off in higher operating temperatures. This fits with reports of new engines operating 30 to 50 degrees higher than previous models. Please explain to the audience what impact this change has on engine oil performance.
Sure, Chris. Let's begin by showing everyone where an engine exhibits the highest temperatures. In our illustration, we see the highest temperatures marked by the brightest colors. As expected, we see bright colors adjacent to the piston cylinders due to the combustion temperatures and the frictional forces between the piston and the cylinders. But I also want to take a closer look at another area in the crankcase where the main couplers and the conrod planar bearings are. Unlike the cylinder liners, these bearings have no direct contact with the engine's coolant. They rely completely on an engine oil's ability to both lubricate and also to carry away heat. So now let's take a look at the symptoms of lubrication failure caused by a sustained high operating temperature, okay? These charred remains are planar bearings riddled with surface damage. The dark patches are oxidized varnish and sludge deposits, and you can see their deeply etched wear patterns leave little doubt this engine oil exceeded its service life. Now, I want to talk a little bit more about these planar bearings. So before showing our next sample, I want to explain a little bit about their composition. Many are plated in layers of differing materials. The top layer is typically called babbitt, It's a dull, soft gray metal alloy or it could be aluminum. The next layer below is often a combination of mixed copper and lead, and finally a steel foundation for support. As these bearings wear, these layers are removed. This is intended as part of their design to protect the engine from seizure. Now, let's look at a bearing set that was taken from an engine after 500,000 miles. You can see clearly the babbitt layer is all but gone, and the copper layer is scored and extremely worn. So once again, we see the engine oil failing long before it was replaced.
So now we've seen the effect of lubrication failure, okay? Describe for us how thermal viscosity breakdown occurs. What are the contributing factors causing this breakdown, and what do we do to combat it?
Okay, this is basic lubrication 101, and great questions. Thermal viscosity breakdown results from many types of complex chemical reactions, but for the sake of our time and your patience, I'll explain what is generally happening. But first, motor oil's function. Motor oil should provide a protective oil film, called a boundary layer, on the surface of moving parts. It should reduce friction and it should carry away heat. Motor oil, though, in the presence of oxygen and high temperatures, breaks down through a process called oxidation reduction, or redox for short. In a redox reaction, oxygen and the kinetic energy that happens from high temperature breaks chemical bonds. This result is called thermal viscosity breakdown. Now, we prepared an example that we can show you. So let's travel deep into the oil film layer between the piston and the liner. Now, oil. The majority of an engine oil is the base fluid. Polymer chains of similar size. I say similar because polymer chain length determines oil viscosity, okay? And the longer the chain, the higher the viscosity, and the shorter the chain, the lower viscosity. So you can see in this image here, this is what our polymer chain looks like. Now, what happens in the presence of oxidized contaminants? These are called free radicals, and they come in and they break polymer bonds, reducing oil viscosity and its ability to maintain an effective oil surface. Smaller chain fragments tend to evaporate. Larger chains tend to morph into contaminants and clump together in a process called agglomeration. Agglomerates thicken motor oil and provide almost no oil film protection, and often filled with abrasive metals and acids, causing surface deformations and corrosion. These free radicals are a huge challenge to oil chemists. Oxygen is everywhere, so these oxide actions are inevitable. In fact, the pursuit of antioxidant protection has become the primary focus in motor oil compared to anti-wear chemistry. This doesn't mean anti-wear protection is less important. What it means is that engine technology has changed.
Right. So to recap, new diesel engines operate at higher temperatures because changes in fuel ignition timing raise ignition compression for more power, combustion efficiency, and NOx emission reduction.
Absolutely. And
between higher operating temperatures, OEM demand for longer oil service life, and a shift to lighter viscosities like 10W30 for fuel economy, this presented significant challenges in controlling oxidation.
It does.
So Terry, please take a minute and tell us how Peak's dual oxidation control chemistry combats that thermal oxidation.
I'm glad. This is an amazing breakthrough. What we identified were synergistic chemical relationships between specific antioxidants and specific surface inhibitors. So they work together. Peak's dual oxidation control chemistry provides a two-fold defense against thermal viscosity breakdown and protects engine oil longer than all previous AOs that have been used in service before. So now I want to take a closer look at the same polymer chain, and we'll show how Peak's dual oxidation control technology works. Our first line of defense is an AO passivator chemistry working synergistically with anti-wear additives on the surface. This AO, the green balls on the left, block metal oxide reactions with free radical precursors. The AO can't stop all of these reactions, but they do significantly reduce their number. And if you inhibit contaminants from reacting with surfaces, you reduce free radical formation. Now, we're going to move in a little bit closer and see what happens when a free radical actually does create. Peak's second line of defense is introducing AO's free radicals find more attractive to bond with than the base fluid polymers. These AOs are sacrificed in the process, but they protect the polymer lubricant. Yes, they deplete as more bonding occurs, neutralizing the AO affinity, but this extends polymer life and the lubricant service. I want to move on to another performance improvement and the significance behind it. This has to do with speeding up air release in the engine oil itself. Now, we're not concerned as much about foam on the surface because Peak's anti-foam capability has taken care of that for years. We're focused on releasing air bubbles so small they're barely visible to the naked eye. Why? Well, Chris, what happens to wet concrete when water freezes?
Well, it expands and creates cracks and fissures in the concrete.
That's correct, yeah. And the same thing applies to air bubbles when they're under extreme pressure. And then if they're on a surface where the oil is and that pressure is dropped abruptly, you get what are called micro explosions, called cavitation erosion. And they create surface pitting, leaving a unique V-shaped surface signature. This is a growing concern in new diesel engine design because of significantly smaller and tighter clearances between moving parts. So our time is running short, and we want to get to the good stuff. And so remember those 500,000 mile bearings?
I do.
Okay. Well, let's take a look at Peak's 10W30 diesel motor oil's performance. And this is on a set of bearings that were at 500,000 miles with oil changes between 60 and 80,000 miles.
And I think you're going to tell me we fared better, right?
Yeah, we'll let the viewers decide though. So these images are close-ups of aluminum-coated top-end main bearings after 500,000 miles. There's hardly any abrasions on these at all. And then we're also going to see these close-ups are Babbitt-coated main bearings. There is some minor scuffing, but for the most part, they're intact.
That is amazing, actually. What a performance difference.
Absolutely. And one last thing I wanted to share with you was an example of a piston liner in a bearing set. But I want to explain a little bit about what's going on with piston rings, because how it relates to the oil is really important. First, the rings reduce the gap between the piston and the cylinder wall to increase compression. They apply motor oil evenly to the cylinder wall in a brushing motion, and this lubricant creates a meniscus to maximize that compression. Finally, what those rings do is they limit as much of the motor oil to keep blow-by from occurring in the combustion chamber. To assist the rings in oil coverage, you'll see inside this cylinder there are etched with crosshatch patterns, in which case this helps the oil better adhere to the surfaces. And historically, at 500,000 miles, these are replaced by vertical abrasions. Okay? Note the crosshatch pattern to start. So these results do speak volumes to Peak's dual oxidation control, chemistry, and this is premium engine protection here we're talking about, Chris.
Yeah, we are. Thanks, Terry. And we're confident your customers will be impressed with Peak heavy-duty diesel motor oil. Peak's two-pronged approach not only inhibits oxidant formation, but binds oxidants that may form to inhibit wear and corrosion for premium engine protection and a long oil life. In addition to these new protection advancements, Peak's full synthetic and synthetic blend formulas significantly improve fuel economy and carry the same OEM warranty protection for extended service. Peak's new quick air release chemistry inhibits instances of cavitation erosion for better engine parts protection, just as Terry laid out for you.
Right.
As traditional, Peak is certified in meeting both American and European standards for automotive engine oil and many major OEMs such as Mack, Volvo, Cat, Cummins, Detroit, Daimler, Ford, and more. Peak heavy-duty motor oils are available in 3 viscosity grades and basically any common package size. Our full synthetic 5W40 delivers real fuel economy, winter startup protection with faster oil flow, and is OEM approved for extended oil drain service. Our synthetic blend 1030 also delivers real fuel economy, OEM approved for extended oil service, and is the new factory fill viscosity for many 2017 model year C8 big rigs. Our synthetic blend 1540 outperforms API CJ4 motor oil performance standards and CK4 oxidation and wear control standards. It's OEM approved for extended oil service, and a conventional 1540 formula is also available in bulk.
That's right, Chris. And to share with you another advantage is Peak diesel motor oils are backward serviceable for all previous API heavy-duty engine oil service categories, and including API's new FA4 oil service category. So we're delivering the widest coverage with the smallest viscosity spectrum and providing inventory convenience. So finally, I want to take a moment to remind our viewers that we do offer a comprehensive engine oil inspection program that helps customers maximize their oil service life, identify potential engine issues before an expensive breakdown occurs, and generally saves you money. This is an affordable program offering real value, and we ask you to contact your service representative for more information. So I want to say, Chris, I appreciate the time that our audience has given us today.
Well, let me say, Terry, real quick, with that kind of presentation, thank you for putting all of this together. Okay, buddy? I really appreciate it. We've needed this kind of support for a long time. But right now, let's open this up to some viewer questions.
Okay. I think we're having some technical difficulty on the viewer questions.
Yeah, there's no questions. So it looks like you did such an outstanding job that all the questions have been answered. So we'll take that as a benefit, and hopefully everybody out there enjoyed what we were able to share with you today. We look forward to working with you guys on our heavy-duty engine oil program.
And please, always feel free to reach out to me, Chris, any one of the folks in our lubrication team, to provide you the technical information support that you need to help make these relationships strong with your customers. Thank you.
Thank you.